Let me tell you a story about Ira Remsen. Ira was a chemist, of course, and he was born in February of 1846 in New York City and died in March of 1927 in California. He was educated at Columbia University in New York City and also in Germany. His most famous discovery was of saccharin, along with Constantine Fallberg. They discovered this artificial sweetener that you find in sweet and low. He also went on to become the second president of Johns Hopkins University. But he really was quite an outstanding chemist. So much so that the American Chemical Society honored him in 1923 with its Priestley Medal, which is named after Joseph Priestley, the first American chemist. And the Priestley Medal goes each year to the outstanding chemist in the United States. It's the highest award given by the American Chemical Society. He was a student once upon a time, of course. He was sitting in the lab one day reading his textbook, and he came across this phrase: nitric acid acts upon copper. Nitric acid acts upon copper. He got to thinking and wondered what this meant. And he knew a little bit about acids, a little bit about copper. He wasn't sure what all of this, what it meant for acts upon me. So he knew about acids, and you do too. They're corrosive, and they're found in many places. And there's citric acid and fruit juices such as orange juice. Vinegar is a 4% solution of acetic acid. In fact, your stomach has acid in it. It helps you digest. In fact, it's approximately 1 molar hydrochloric acid that's in your stomach. So you know a little bit about acids. Ira knew a little bit about acids. Copper is a metal. It's shiny until you get a patina on it, a copper oxide coat. That'll happen with time. It's malleable and ductile, which means you can pound it into a flat shape, or you can pull it out into a long, thin wire. And you probably know that it conducts electricity and heat. And Ira knew those things also back in his day. We find copper, as we mentioned, in wires that help conduct electricity. At the bottom of cooking pots and pans, it's a very good conductor of heat. And of course, if we find it in coinage, it's a coating, the cladding on pennies nowadays. So nitric acid acts upon copper. So Ira wondered what it meant for nitric acid to act on copper. So he reached in his pocket and pulled out a penny and put it on the table. Remember, this is the latter part of the mid part of the 1800s, 1860, 1870, somewhere in there. He's a student in school, and they didn't have electricity or indoor plumbing or anything like that. So he reached in his pocket, got a penny, put it on the table, got the bottle of nitric acid, and proceeded to put a little bit of nitric acid on the penny and watch what happened. And so for safety's sake, I'm going to do it in the hood and put it in a beaker. You can see the penny, it's got a little bit of brown coating on it from the copper oxide that's developed on it. And the nitric acid was a clear colorless solution, if you noted beforehand. Pour that on there, now it's starting to bubble and boil. And it's generating this brown smoke. And so in your mind's eye, see Ira hovering over his wooden table, watching this take place. All this brown smoke filling. He's going, wow, this is really neat. And it is really neat. So nitric acid acts upon copper, and it's going to town. Well, all of us now, he's getting all choked up about things, that these brown fumes are coming out. And what's he going to do? Well, he decides he needs to get rid of this experiment. And so he grabs the penny, dashes over the window, and tosses the penny out the window. And so he's discovered what it means for nitric acid to act upon copper. But now, what is he discovering? he's discovering that nitric acid acts on fingers because his fingers feel like they're on fire from this concentrated nitric acid. And so 1860, 1870-ish, what's he going to do? He doesn't have any running water. He's in the lab. You need to get this stuff off your hands. What are you going to do? He wipes his hands on his trousers. Oh, it feels so much better. Get that nasty stuff off his fingers. But then, in short order, he looks down at his pants and they're starting to get eaten away. So Ira has learned nitric acid acts upon copper, nitric acid acts upon fingers, and nitric acid acts upon trousers. So he learned a lot that day. It was no small investment to begin with. A penny was worth something back in those days. But it also cost him a pair of trousers. And so the best way we discover things in science is by doing experiments. Now you need to do them safely. Ira didn't particularly do it very safely, not at least compared to 21st century safety standards. And you always need to have somebody watching you. And if you did this experiment, you need to do it in an exhaust hood. You need to have some spill cleanup nearby in case you have a spill. You need to wear gloves, long pants, long sleeve shirt, eye protection, etc. And so you need to do experiments safely. Ira is just amazed at what's happened. And he remembered this all his life and recorded it in his journal and passed it along to us. Well, I've stopped the video and let me continue. Let's see what happens a little bit further. So we're it's just literally boiling away, giving off gas anyway. This brown gas that's very noxious. And we'll add some water to it to quench the reaction. It's this pretty blue solution. And you sort of see the shiny penny down there. We burned off that oxide, or not burned off, but removed that oxide coat. And so that blue solution that you see is really copper ion. It's gone to copper 2+. We've had an oxidation reduction reaction take place, and the copper has lost electrons, and it's been oxidized. We'll talk more about that in a later chapter. This is Ira Remsen's experience with nitric acid and with copper.